Okay, today in this video, we are going to be talking about two sample z-tests for significance. And when we do these kinds of tests, we need to have a couple assumptions that must be in place for these tests to happen. So the first assumption is that all of the data is normally distributed, so it meets the normal curve. The second thing is that we need to know the standard deviations for both of the samples that we're testing. And then finally, we need to understand that the null hypothesis is that both samples will be the same, or that they'll equal each other, the averages of them will. The alternative hypothesis is that they are not the same. Now, these assumptions can come in a couple different ways. Either we can assume that they're not the same in terms of they're just not equal, or that one is greater than the other, and this will tell us how many tails on our z-test we will have. And in case you don't know, this funky little symbol that I'm drawing that looks kind of like a U is the Greek letter mu, and we use that a bit in statistics. Okay, so the formula for a two-sample z-test is going to be z equals x bar 1 minus x bar 2 divided by the square root of sigma 1 squared divided by n1 plus sigma 2 squared divided by n2, where x bar equals the means, so mean 1 and mean 2, sigma 1 and 2 are the standard deviations, and n1 and n2 are the sample sizes. Okay, so now we're going to do a sample problem. So the problem we're looking at is the average IQ of people in two cities are normally distributed and both have an SD of 15. A researcher believes that they are different. She takes samples from 20 people in each city and records their IQ. The average from city 1 is 100.65 and from city 2 it's 108.8. So how do we know if this is going to be a two-sample z-test? Well, first we need to look at the problem, and we can see that there says there are two cities, so we know this is a two-sample test. Secondly, we need to remember our assumptions. Firstly, they have to be normally distributed, which it is, so that's good, and they need to know the SD, and we do know the SD, so that's going to work as well. So now we're going to set up our null and alternative hypotheses. The null hypothesis is that mu1 and mu2 are equal. The alternative hypothesis is going to be that mu1 and mu2 are not equal. And we're going to be able to determine if this is a one- or two-tailed test based on the very first sentence in that little bullet point. A researcher believes that they are different. If this were to say that the researcher believed that City 1 had a higher IQ than City 2, or that City 2 had a higher IQ than City 1, that would be a one-tailed test. But because the researcher just believes they're not the same, we're just going to have a two-tailed test because it could be either higher or lower. So we just can very clearly see this will be a two-tailed test. Now we're going to write down some information from each city. City 1, we're going to write down our x bar, which is going to be 100.65. We're going to write down our sigma, which is going to be 15, and our n, which is going to be 20. And then from city 2, we're going to do the same. X bar is going to be 108.8, theta is going to be 15, and our n is going to be 20. Now, it's important to note that theta and n are okay to be different. They're not always going to be the same. Okay, so now that we've collected all of our numbers that we need, we're going to put that into our formula, which is going to be z equals x bar 1 minus x bar 2, which is going to be 100.65 minus 108.8, and then we're going to divide that by the square root of 15 squared divided by 20 plus 15 squared divided by 20, which is sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. So when we calculate that all out and we get all the way down to what our z-score is, the z is going to be negative 1.718. And the p-value that calculates out to, and however you're going to calculate that, whether you have a chart on a piece of paper or whether you're using the Fun with Stats Bitbucket website or whether you're in a calculator, you're going to calculate that out to get your p-value, and the p-value is going to be 0.0858. Now we need to remember that our significance level is 0.5, and anything above that is going to be a fail to reject the null. So because of that, we fail to reject the null in this problem. All right, I hope that this helped you guys learn a little bit about two sample z-tests and how to figure out how to calculate them and how to set them up. If you have more questions, these links are super helpful. Good luck doing stats.